Okay, so hello everyone, welcome to another video. And today I want to introduce you to this problem. So if we go to Leetcode, so this is the third problem in the dynamic programming plan, ultimate DP plan. Okay, if you go here and if you go to this option, you will find this will be the third problem in the first plan, dynamic programming first. Okay, uh, yeah, this one. I want to introduce you to this problem first. Rather, let's solve this one first. I think this will make sense. We'll solve both of them together, so that's more clear to us. And first one, I will just introduce it. Okay. So the problem is easy problem, and it has been asked in Amazon, Adobe, Bloomberg, and what all? Okay, Anagaro, Uber, Microsoft. So it's a pretty common problem which usually appears in the interviews, coding interviews. So I'll read the problem first. It says you are climbing a staircase. It takes n steps to reach the top. Each time you can either climb one or two steps. In how many distinct ways can you climb to the top? Okay. So let's just try to understand the problem first. So there has been given a staircase, and there are n steps to reach the top. So let me open the whiteboard as well, just so that we can visualize the problem as well. So we have n steps. Okay, each time you can either climb one or two steps. Okay, so maybe you will start from here, and you can either climb one or you can climb two. In how many distinct ways can you climb to the top? Okay. So let's take these examples. For n equal to 2, either you can, which is, okay, either you can do two steps of size 1, that is one way. Another way is uh, just do two steps. That is how you can reach the top. See, one step plus one step or two steps. One step plus one step or two steps. There are two ways to do this. For n equal to 3, similarly, 1 plus 1 is possible. 1 plus 2 is possible. And yeah, 2 plus 1 is possible. Yes. Third step. Okay. So for n equal to 3, there are three ways to climb. For n equal to 1, how many ways? Only one way, I think. Okay. Now we begin to see, try to build a pattern actually. For n equal to 1, there is one way. For n equal to 2, two ways. N equal to 3, three ways. If we go to 4, how many ways do you expect? Let's try to find out for this one as well. This is one way possible. Another way possible is 1 plus 2 plus 1. I think total 5 ways are possible. Okay, all these. Yes. So you will see uh, when you construct it for 5 as well and 6 and so on, you will try to see the pattern, okay? This pattern is nothing but Fibonacci sequence. And if this is a Fibonacci sequence, we can just write the code for Fibonacci and we'll get for given n how many ways are possible. Given an n number of ways is a Fibonacci sequence. Okay, so we will try to write a DP solution, but we will try to build it up from ground. Okay, basically from lower n values to the highest n value possible. So we will begin with 1, 2, 3, and so on to n. So this is a bottom-up approach. Okay, we will build the solution bottom-up, like we did for the Fibonacci problem. Okay. Mm, let's try to write the solution for this one. Let's get this problem solved very quickly. Uh, we just need to take care of the base case. Okay. So n can expect values from 1 to 45. What we can do is if n is equal to 1, then just return 1, I think. And we can build a memoized uh, array which will help us memorize. Okay, we will store the DP grid for each of these number of ways. So the size will be n only, and what else? So DP1 we can initialize to 1, and from starting from 2, we will try to build our solution in a bottom-up fashion. So DPI is dependent on the value of DPI minus 1 and DPI minus 2. Okay, sorry, DP0 will be 1. So this means that DPN minus 1 will provide us total number of ways, distinct ways, sorry, to climb the nth top. Okay, and we should be able to return directly this thing. Uh, is there any mistake in the code? Let's see. Let's try to run it and we'll just figure it out. Okay, we have to initialize two values initially. And yes. So if n is equal to 1, let's take this scenario. So it will return 1, fine. If n is equal to 2, it will create an integer array of size 2 and it will return 2 in this case, okay? And for further, if the n is greater than 2, it will go into this loop and try to construct this. Let's try what is is happening. Yeah, it's accepting. Okay, let's try with a bigger number. Okay, it is working. So why I'm not doing the whole recursion thing? Because we have already discussed that in the Fibonacci solution. So this is nothing but a Fibonacci sequence that we identified. And we can just use that solution directly from the Fibonacci problem. Okay. Um, for this one, time complexity will be O of n, and space complexity is also O of n. Okay. Because we are using a DP array. We can do the optimization similar to the Fibonacci sequence problem as well, where we can just maintain three variables and keep on interchanging them. Because ultimately, see, we are only using three variables, right? We have only three variables. So we can make use of that fact and we can just switch the values between three variables accordingly, and we'll be able to optimize this to O of 1. But this is good enough for this problem, okay? So if you submit it, so it's accepted, and the runtime and memory is also quite good. So, okay, I think that should be enough for this problem. In the another video that I will record after this one, I will be talking about this problem, which is minimum cost climbing stairs. It's a little bit modification over this problem, okay? So, and it has been asked in Amazon, Apple, Bloomberg. So, okay, see you guys in the next video.